Hi class, we're going to look at section 2 on chapter 22. Uh, it's about the earth, the moon, and the sun and how they relate to each other and move around. First thing we want to look at is the motions of the earth, and there are three. In the book they say there's two main motions, and they later on go talk about a third one. I'm just going to go ahead and summarize all three. The first one we want to look at is the Earth's rotation, and that's this one right here. It's the Earth's spin on its axis. The Earth takes 24 hours a day to spin completely all at one time all the way around its axis. The other term is revolution, sometimes confused, but on the revolution, it's the orbit around the sun, and you can see the trace of the path here. This is the orbit of the Earth. Notice it's an elliptical orbit around our sun. And the third type of movement is called precession, and it's the picture right here at the top. And basically what it's showing is precession is the movement of the axis of the Earth, and it's kind of a wobble, like a top. If you spin a top and you let it spin for a while, then it starts slowing down, and the top starts to wobble back and forth. And so there's some slight movement there with the axis of the Earth. The next thing we want to look at is there's the Earth revolving around the sun. There's two terms that you're going to see, perihelion and aphelion. Now, perihelion is January 3rd, and what that's when the Earth is closest to the sun. So it would be like from here to here is perihelion, and aphelion is July 4th. Oh, I'm sorry, I put and that would be right here. That aphelion is when the Earth is farthest away from the sun. Perihelion closest, aphelion farthest away. Now, a lot of people feel that, or initially you'd be like, well, when the Earth is closest to the sun, that would probably be the warmer time of the years, and when it's farthest away, it would be the winter. As you know, notice the date. It's not true. That distance away from the Earth to the sun doesn't play into the reasons that we have seasons. And that really goes into the next thing we want to talk about is the seasons and the axis tilt. So we have the Earth, and it rotates around the axis, which we only talked about. This is the rotation. It takes 24 hours. There's a tilt. There's axis. It's 23.5 degrees, and this is the real primary reason why we have our different seasons, is that we have this incoming solar radiation right here from the sun, and say we're talking about the northern hemisphere. Notice that the tilt of the axis is tilted away from the incoming solar radiation, and so now the sun rays are not as direct. And I look at it, think of it this way: take a flashlight. If you take a flashlight and just beam it straight into the screen, it's going to be pretty much a circle. It's going to be direct rays. But if you tilt that flashlight and point it at the screen, now the beam of that light is kind of spread out, and so it's not as direct, and so the energy is not as focused. And this is what happens in the wintertime. That tilt of the axis is away from the sun in the northern hemisphere, and so the sun rays are not as directed, not as intense, and so that we have those cooler temperatures. Now during the summertime, the Earth's axis is tilted towards the sun more, and so now the sun rays are more intense, and that's when we get those summer times. A couple things we want to look at with the seasons. And I don't know why this didn't show up, but We'll just draw it in, I guess. We got the sun right here in the middle. Alright, and let's change it. We got the earth right here. We'll look at 4 different positions. Sorry for the drawings, guys. The first one, let's go ahead and put the axis right here tilted towards the sun, and that's during the summertime. The beginning of summer is called the summer solstice, and let's get some exact dates, and I always have time. The summer solstice is during June 21st and June 22nd. Then after the summer solstice, we're going to be going into the autumnal equinox, and that's where the axis is straight up and down. And those dates is September 22nd and 23rd. And as we move through the seasons, now the axis tilt is away from the sun, and that is the winter solstice. The winter solstice is during the month of December 21st and the 22nd, and then as we move on through the seasons, the axis tilt is back straight up and down, and now that's the vernal equinox, or sometimes we call it the spring equinox, and that's March 20th and 21st. We know, equinox, on those days of the spring and fall equinox, equal day and night. That means the Earth is, compared to the Sun, is the axis tilted towards the Sun is, it's not tilted towards or away from the Sun, and so we have equal day and night. And during the winter solstice, that's the shortest day, and then the summer solstice would be the longest day for us. So again, the axis tilt really plays into the reasons why we have the seasons, and that revolution around the sun. Now the next thing we want to look at is the motions of the Earth and Moon systems. As we had perihelion and aphelion for the Earth around the Sun, we have this for the Moon. Realize that the Earth has one satellite. It's called the Moon, and it revolves around the Earth. And the two terms we have is perigee and apogee. Perigee right here is when it's closest, the Moon is closest to the Earth, and apogee right here is when the Earth and Sun are the farthest away. Let's go ahead and let's talk a little bit about the Moon rotating around the Earth. There's two numbers that we want to look at, and one of them we look at is how many days does it take for the Moon to go completely through the Moon phases, the lunar phases, and that is 29.5 days. And that, they give a specific name, and that's called a synodic month. Now, what we also look at is a different terminology, and that's called the sidereal month. And that's actually, how long does the Moon rotate around the Earth, and it actually takes 27 1/3 days. Now, here's a unique thing. So it takes the Moon 27 1/3 days to go all the way around the Earth, and also it takes 27 1/3 days for the Moon to spin on its axis. So we'll never, we will only see one side of the Moon always. We've never seen the back side of the Moon except for a satellite or the astronauts up in space. Another thing to think about is the direction that the Moon orbits the Earth, and that is in a counterclock direction, so it would be going this way around the Earth. Okay. Next thing we want to look at, and you'll see more of this in the lab that you're doing, is the phases of the Moon. we all start out at the new moon phase, and that's right here. Basically, you're not going to see the moon at all. The reason why we see the moon is because it's the sun reflecting off the lunar surface back to the Earth. And so for the new moon phase, you have the sun right here, and it's shooting the rays at the moon. And notice that there's no reflection into the Earth, and so that's why it looks like there's nothing there. And as it's moving through the lunar phases, you'll see terms called waxing. That means that the lunar phases are increasing, and then you go to the first quarter, and then notice we got a gibbous, and then the full moon. We see the whole moon is because the sun rays are reflecting off the moon, and so we can see the complete moon. And then when the moon is, the lunar phase is disappearing, we see a term called waning. That means we're not seeing as much of the moon now. It's disappearing back into the new moon phase. Again, that takes 29.5 days. Now, again, that's a little different from the moon rotating completely around the Earth, and that takes 27 1/3 days. And the last thing we want to look at is solar eclipse and the lunar eclipse. Solar eclipse is when the moon goes in between the sun and the Earth. And what you'll see here is when everything lines up, when you're in the what you'll see is the image down here, where you'll see a black spot and kind of a glowing crown all the way around the moon. That's a solar eclipse. And then the lunar eclipse is when the Earth goes in between the sun and the moon, and what you'll see is the moon will turn a very copper color, and that's what you'll see with that one. If you have any questions during class, just let me know, and make sure we're reading the section of the text. It's a little bit longer than normal, and completing everything and getting those things into it.